Propagation of errors. This is the final area of the error analysis. Propagation. Propagation means what? Suppose two quantities are measured, there is some error. When those two quantities are added, or subtracted, or multiplied, or divided, or any other operations. So in the case of operations, after doing the operation, what will happen to the individual errors? Whether those individual errors are propagated or updated or become addition or subtraction or multiplication or division, whether they are also operated according to the given operation or not, what will happen to the error? So that is about the propagation of errors. In propagation of errors, there might be addition or subtraction or multiplication or division. Remember, in addition or subtraction, absolute errors are added. In addition and subtraction, absolute errors are added. In multiplication and division, percentage errors or fraction errors are added. This is the working rule. So let us discuss about the addition and subtraction. Let me take two values here. Let us say given data is something like this. A value is given as A with absolute error and B with absolute error. And remember, question may be given in three ways. This question. One method is they will give you true value with absolute error. Or sometimes the question may be given or numerical may be given in terms of the percentage errors, or the numerical may be given in terms of the least count instrument. They may mention something like this: yeah, this length is measured with screw gauge, this length is measured with vernier calipers, this is measured with millimeter calibrated scale or centimeter calibrated scale. Simple, they won't mention the error. So always remember, if they won't mention the error, just they give the instrument, that means least count will be error for that, maximum possible error. So that will be considered as the absolute error. And now, just now we had a discussion, right? In the case of addition or subtraction, which errors are added? Absolute errors are added, and the operation is the addition. So for addition operation, absolute errors must be added. That means delta A plus delta B, because addends are A and B, right? So A error is delta A, B error is delta B. Those two things must be added. So delta R is delta A plus delta B. This is the working rule. And final conclusion. We know that delta R equal to delta A plus delta B. In this case, first case, the given data is delta A, delta B, directly added. And the operation, main operation is A plus B, directly added. And in the case of this, how to handle? Percentage delta A into A divided by 100 will be your percentage delta, original true value divided by 100 will give you the delta A, delta B value. And after getting these two, you can get to this step. That is the actual working rule. Now, suppose if the least counts are given, simple least count is itself is the absolute error, and after getting these two things, come here. It looks like a little bit clumsy, right? So let me again give you an idea with proper alignment. Now let us see. Now I am just modifying the structure. Given data will be in three formats. The first format will be in terms of the absolute error. And the working rule is R equal to A plus B, delta R equal to delta A plus delta B. And a given data may be given in different way in terms of the percentage error. Given data may be given in another way in terms of the least count. Simple. So here it is very easy. What is the working rule here? Delta A plus delta B. So for first kind of the data, I have delta A plus delta B readily available with me. So for this kind of the question, I can solve it directly. But for this, I need to process. I need to do one more step here to find out the delta A. What is delta A? Multiplication of the given values divided by 100. So A into percentage divided by 100. That will be my absolute error delta A. Same delta B equal to B into percentage delta B by 100. After getting delta A, delta B, take these values and substitute here. That is working rule. Suppose in this case, least count is given. Least count itself is delta A, I mean absolute error. So I can write delta A as LC1, delta B as LC2, and I can take these values and substitute here. So whichever the way of the given data, now I am ready, I know how to handle that. First data, direct substitute. Second method, just process. Third method, this is also direct, and substitute here. And after this, I'll observe the options. So in the options, you may be given any of this way, r plus or minus delta r delta r by r, and percentage delta r equal to delta r by r into 100, r plus or minus percentage delta r. So whatever the way, you have to be process all these things. So the question may be representation of in terms of the absolute error, or fraction error, or percentage error, or representation in terms of the percentage error. So these are the four kinds of the numericals possible with these three different kinds of the given data. So three different given data with four possible questions, 3 into 4, 12 kinds of unique numericals for addition operation. For subtraction again, 12 kinds of the unique models. And let us see in the case of multiplication and division. So in the case of multiplication and division, please keep in mind, for multiplication, absolute errors are added or percentage errors are added. So in the case of multiplication, if the given data is this one, absolute, use the formula relative errors are added, that is delta r by r equal to delta a by a plus delta b by b. In the case of percentage error data, add percentage error directly. Add percentage error. Percentage error is directly percentage errors data addition, percentage delta a plus percentage delta b. And from this, you can get the relative error. Or from this relative error, you can get the percentage error based on the question. Suppose if the given question is LC1 and LC2 or least count, follow the same method of the first one. We know that LC1 itself is the delta A or delta B. So now apply the working rule as percentage, fraction error is equal to sum of the fraction errors. So LC1 by A plus LC2 by B. And after this you can find out the percentage error. So first kind of the data you can find out the relative error or percentage error. Second kind of the data you can find out the percentage error or relative error. Third kind of the data you can find out the relative error as well as the percentage error. And from these, all these two, you can come to the original based on the options and questions. You can figure out whichever is possible. Again in this case also, multiplication and division, either fraction errors added or percentage errors added. So here for each operation, addition, subtraction, multiplication and division, you have 12 unique models and 4 operations, 48 kinds of the unique application questions are possible in terms of the numericals of the physics in error analysis. And this is how you should understand, this is how you should think, how the examiner will give you the numerical here. Now let me come to the next part, or else once let us see division also. Division, given data will be in 3 ways again, and the operation is A by B, and the first case delta r by r equal to delta A by A plus delta B by B, and after finding out the fraction error I can get the percentage error. And in the second case, the given data is percentage error. So I will apply the rule percentage errors are added. After getting this, I can get the fraction error from this data just by division of the 100. And this one, these are all absolute errors. So first I will process the fraction error equal to sum of the fraction errors. And after getting fraction error or relative error, I can get the percentage error. So whichever the data is given, according to that, according to the question is being asked, you can process the things. Again, you will be getting 4 kinds of the questions. Yes. So as I told you already, you have 48 unique models in propagation of the errors for addition, subtraction, multiplication and division. I think you got the complete idea about propagation of the errors.